Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, I am Abdel Boulsnan from Constantine III University in Algeria. Happy to present our paper entitled DZchatbot, a medical assistant chatbot in the Algerian Arabic dialect using sequence-to-sequence model. So first we will start by presenting the motivation and the problem statement in this work. After that, we will move to present the contribution of this work. Then we discuss the obtained results, and we end this presentation with a conclusion and some perspectives. The healthcare field is one of the most important fields in our lives. Recently, in light of the rising incidence of rapidly spreading infectious disease such as COVID-19, many people have been afraid to leave their houses, go to doctors for fear of infection. But on the other hand, sometimes people get shy to ask about illnesses and symptoms, like women who don't make earlier detection of breast cancer, as an example, which will lead to very bad results. Also, in emergency cases, most of us do not know what to do. In addition, many patients cannot express properly their feeling to doctors with their simple dialects. To deal with these problems, several chatbots have been proposed in the literature, based on several types: rule-based, retrieval-based, and generative-based, and in several languages such as English, Chinese, and Spanish. However, with these problems, because these works rely on an in-depth comprehension of the natural language, use it to analyze emotion and detect symptoms from text, their use is mostly limited to their language and cannot be used for other natural languages. So we proposed a new DZchatbot to solve these problems and deal with the Arabic Algerian dialect. To the best of our knowledge, no previous research has used texts in the Algerian Arabic dialect to simulate medical conversations and hence create a medical assistant chatbot. The proposed chatbot provides general medical advice and consultation that will reduce the risks until the hospital is reached. So the aim of this study is to propose a new chatbot to help Algerian patients and improve healthcare delivery. The following figure describes our proposed methodology architecture for creating the DZchatbot using deep learning and NLP. It consists of 4 modules designed to process and analyze texts written in the Arabic Algerian dialect. The initial module consists of data collection, which is the most important setup in building our chatbot system. Since our interest in the healthcare field, we need to collect a lot of patient questions and find their answers to build a data set with questions and answers pairs. So we collected many questions on general medicine using many methods, from Algerian public Facebook groups, from some famous doctors' websites like WebTab, also from interviewing people, and by using some Google Forms link. After we finished collecting the questions, we presented them to a group of specialists, including medical students and doctors. Therefore, this process allowed us to collect 2,115 pairs of questions and answers on general medicine writing in the Algerian Arabic dialect. This data is available on Kaggle via this QR code. The second module includes all pre-processing techniques used to handle the Arabic Algerian dialects. For that, we use some popular techniques in NLP to prepare the data by cleaning up noise like stop words, punctuation, and terms that are not important in our context. The third module encompasses feature extraction techniques that turn text posts into magnificent representations. The idea is to apply a tokenization on the whole data, questions and answers, to represent all Arabic words by integers. So we construct two binary matrices from questions and answers, tokens representing the position and the interaction between words in each text phrase. The first matrix is called encoder input data, which is created from questions data, and the second matrix is decoder input data, which is created from answers data, where each answer must be tagged by start and end, where the model should know when to start and to end each answer. We proposed two sequences models based on LSTM, GRU, and BLSTM. Sequence to sequence is a supervised learning algorithm where the input is a sequence of tokens, for example, texts, audios, and the output generated is another sequence of tokens. As you see in the sequence-to-sequence architecture, we have an encoder and decoder. As we explained previously, the meaning of each sentence will be stored and represented by a vector in the encoded input data matrix. The encoder receives all the questions as integers and produces the encoded state. At the same time, the decoder receives all the answers surrounded by start and end tags as integers and use the encoded state produced by the encoder. Based on the same sequence-to-sequence architecture, we propose several models based on GRU and BLSTM. Where we should note that LSTM, GRU, and BLSTM are all RNN deep learning models, differ in the state between the encoder and the decoder. More precisely, LSTM has hidden and cell state. GRU has only hidden states, and BLSTM has forward hidden and cell states, and also backward hidden and cell states. Finally, a dense layer, as we see here, with a softmax activation function is connected to the decoder output in our models. So in the experimental study, 80% of our data were used to train the model, while 20% is used to test the model. After the models completed their training and we do some tests on them, the following plots represent the loss evolution during the training phase. The loss in all three models is decreasing, but GRU is the best one. So we see that GRU model better learned than the other. These figures represent a comparison of training and testing accuracy and loss. We see that both GRU and LSTM record the best performance compared to BLSTM. In all three models, the loss in testing is too high compared to training. And this is because we are working on data that the model have not learned before. By using precision, recall, F1 score, and accuracy metrics, for training data, GRU achieves the best performance. On testing data, chatbots in all models poorly performed on that data that they had never learned before. Other results show that on testing data, chatbots in all models performed poorly on that data that they have never learned before. And hence, the number of unexpected answers, NC, was too high in these models. In another analysis, we see that the max words in the answers are almost like the average number of words in the collected corpus, around 6 words, either for the train or test data sets. Therefore, this confirms our curiosity about the effect of sentence length on the chatbot performance. So we made a simple conversation with our DZchatbot. This figure shows the obtained result, which confirmed the remarkable performance of our DZchatbots. As a conclusion, in this work, we propose a new chatbot called DZchatbot to help patients and improve healthcare delivery in Algeria. The proposed chatbot adopts the Algerian Arabic dialect to communicate with a large number of patients in Algeria. In future works, we will collect more data to enrich the Arabic medical resources and to improve the chatbot's result and accuracy. Thank you for your attention.